All right, so these last two problems, and this one is just a little tricky. So I wanted to show you this, and so let's just start out doing what we know to do, and that's to change. The first step is to change this to a multiplication problem. I have 2 minus x over 8 divided by x minus 2 over 6. So let's change that to a multiplication problem. Remember, your first one's always going to stay the same. And your second one, you're going to flip. So instead of x minus 2 over 6, I'm going to have times 6 over x minus 2. So all we've done there is we have flipped the second fraction, so to speak, and changed it to a multiplication problem. All right, well, let's look and see what we can cancel out. Notice this is 2 minus x and this is x minus 2. They're very similar, but I cannot cancel them out unless they are exactly the same. So those can't cancel out as they are. But let's look at 8 and 6. Those have a common factor of 2. So I can factor out a 2 there and make that 4 and then make this one 3. So I'm left with, I'm going to put my number first, 3 times 2 minus x over 4 times x minus 2. Now, again, 2 minus x and x minus 2, they're very similar, but they are not the same. So you might think, well, I'm done. But there's one thing that you can do to change these, okay? So I'm going to come back down over here. I'm going to rewrite this just to give myself more room. So I'm just rewriting what we had gotten. Okay, so whenever you see two parentheses there that are almost the same, 2 minus x and x minus 2, what you're going to do is you're going to take one of these and you're going to factor out a negative 1, okay? So let's keep our 3 over 4, okay? And I'm going to factor out a negative 1 from 2 minus x. So I'm going to say times negative 1. All right, well, what happens when I factor out a negative 1? Well, that changes the signs of everything in the parentheses. So now this becomes a negative 2 plus x, right? Because negative 2 times negative 2 is positive 2, and negative 1 times positive x is minus x. So all I've done is I've factored out a negative 1 from this 2 minus x. And remember, on bottom, I'm not going to factor out a negative 1. I have x minus 2, right? Well, is there another way that I could write negative 2 plus x? Yes, I can use the commutative property, and I can flip those around. In addition, you can write it backwards. You know, like 2 plus x is the same as x plus 2. So I still have my 3 times negative 1, and I can rewrite this, because it's a positive x and a negative 2, I can rewrite this as a positive x and a negative 2, x minus 2. As long as I factor out a negative 1, then I can switch those around. And notice, now, and I have 4 times x minus 2 on bottom, now I can cancel those out. Sorry, move that over a little bit. So again, whenever you see them look like this, where it's 2 minus x minus 2, oh, they're almost the same, but they're not quite. Always factor out a negative 1 from one of those, and then that changes the sign, and then kind of use your commutative property to flip them around, and now they can cancel out. And I know that's really tricky. If you need to watch kind of rewind and watch that again, you can. But whenever they look almost the same, x minus 2 and negative 2, whenever they look almost the same, 2 minus x and x minus 2, factor out a negative 1 from one of them, and that's going to solve your problem. Okay, because x minus 2 and negative 2 plus x are the same thing. When you use your commutative property, you can write that negative 2 plus x as x minus 2. And now these can cancel out. But notice, I still have my negative 1 here. I still have my negative 1. So that has to be included in my answer to give me negative 3 over 4. And my x minus 2 is canceled out, and that's my answer. So use that factoring out of -1 so that those two binomials can factor out. Okay, last one. Now, this one is going to have a lot of different steps. And so I'm going to use some paper to kind of show that you're going to use the same thing you've used before to factor these out. So notice I've got all these binomials. These are trinomials. And the first thing I'm going to do is I'm going to rewrite them using multiplication. So I'm going to rewrite this first one just as it is. 3x squared plus 10x plus 8. I'm going to change it to multiplication, and I'm going to flip. I'm going to put the bottom one on top and the top one on bottom. All right. Now, what I'm going to do is I'm going to have to factor out each one of these separately. And I'm going to use the process that you already know. So I'm going to kind of show it here on another sheet of paper. And I'm going to move pretty quick because y'all can slow it down if you need to, but I want to make sure I don't make this too long of a video. So remember, you're going to use your process that I taught you. You multiply those and you bring that down, and I'm going to say what adds to make -4 and multiplies to make -12, and that's going to be a -6x and a plus 2x. Oh, yeah. Bring down your outside, and then you're going to break them up. 3x is your common factor. X minus 2 plus 2. X minus 2. Just again, factor out a common factor. If you need to go back and watch, that was the 3.4 lesson. 3.3, I think, in 3.4 lesson. Okay, so what I've done is I've factored this first one here. 3x plus 2 and x minus 2. I've just factored this one out, and that's what I got. So I'm going to do the same thing on the bottom. 3x squared. Let me move that over here. 3x squared plus 10x plus 8. I'm going to factor that out, move that out of the way. So do the same thing. Multiply those, make 24x. What adds to make 10 multiplies to make 24. That's going to be a 6 and a 4, because 6 plus 4 is 10, and 6 times 4 is 24. So this becomes 6x and 4x, 3x squared plus 8. And again, since y'all already knew this, maybe you could pause my video and try to work it out on your own, see if you can get it, and then you can kind of go back and walk. Oops, and I almost made a mistake there. I need to factor out a 3x. So 3x, and I get x plus 2 plus 4, x plus 2. Good. So I've got 3x plus 4 and x plus 2. And again, I know some of these, if you need to do by trial and error, you can. So on here, again, I'm using my 2 sheets of paper here. So here on bottom, I have 3x plus 4 and x plus 2. All right. Now I need to factor out this one here. So over to my other sheet of paper, and I've got 3x squared minus x minus 10. I'm going to factor that out, multiply -30x. What adds to make -1 multiplies to make -30. Well, 6 and 5 are 1 apart, and those multiply to make 30. So I need a -6x and plus 5x to get my -1 when I add them. Bring my outsides down. I know sometimes I use parentheses. Doesn't really matter. And I'm going to take out a 3x. No, that's not right. Up, x squared. There we go. 3, didn't bring down my x squared. So 3x, and I have x minus 2 plus, this has a common factor of 5, x minus 2. There we go. 3x plus 5 and x minus 2. So that's my next one over here. 3x plus 5 and x minus 2. This is a very long type of problem, so I just wanted to show y'all. Y'all know how to do it, but it's just time consuming. Oh, I'm going to use the bottom half of this too. I ran out of paper. I don't think I have another sheet. All right, so my last one I've got to factor is 9x squared plus 21x plus 10. All right, so factor these out. These are a little bit bigger numbers, but I think we can do it. Let's make a 90x. What adds to make 21 multiplies to make 90. All right, so you can do, let's see, 9 times 10. That's not going to make 21. You've got, let's see, gosh, I think I have it written down on a sheet of paper. I don't think I wrote down what I needed to do. 3, 15, I think it's 15. 15 and 6, there we go. 15 and 6. I'd worked this earlier and I don't have my paper with me. So 15 times 6 is 90 and 15 plus 6 is 21. See, it took me a few minutes to figure it out. All right, so 15x and 6x, bring down my plus 10, bring down my 9x squared, factor out a greatest common factor. Oh. So I've got 3x, x plus 5, plus 2, no, hold on. No, 3x, there we go. 3x times 3x is 9x squared. There we go. There we go. Okay. See, and that's the thing. I knew I needed a 3x here, and I only had an x there. And remember, these have to be the same. So if that happens, just look. I had made a mistake, careless mistake there. So, all right. So, and I've got 3x plus 5 again. So my answer is 3x plus 2 times 3x plus 5. I know this is a really long problem, but we are about done. So, for this bottom one, when I factored it out, 3x plus 2, 3x plus 5. All right, so now we look and see what can we get rid of? What can we get rid of? What do they have in common? And remember, they have to be either top or bottom or diagonal. You cannot cross out anything that's just directly across from each other. So it looks like I have a 3x plus 2 and a 3x plus 2. That's good. I've got 3x plus 5, 3x plus 5. And doesn't look like there's anything else. So my final answer is going to be, I've got x minus 2 on top, and you can write that as x minus 2 squared, or I'm sure you could put x minus 2 times x minus 2 if you wanted to in MyLabs Plus. I would think that they would take that as well. And then on bottom I have 3x plus 4 times x plus 4. So some things are going to have a lot that cancel out, and some are not going to have as much that cancel out, and that's okay. All right, let me know if you have any questions.